Guys, happening once again, my beloved scholars. Jam pass question 2001, question number 49. A capacitor of 20 times 10 raised to the power minus 12 farad and an inductor are joined in series. The value of the inductance that will give the circuit a resonance frequency of 200 kilohertz X. Our question is centered on series resonance circuits. Series resonance circuits. Okay, before we solve the question, let me give you a little idea of resonance circuits. A resonance circuit is the circuit that is most preferred in telecommunication. Radio stations, television, internet, they all operate on resonance circuits. It permits interaction or assessment of information. Resonance circuits. Okay, let's see. Let's get the parameters in our question. Okay, we'll start with what capacitance of a capacitor given. The capacitance of the capacitor is 20 times 10 raised to the power minus 12 farad. Then we have inductance as the unknown. Inductance, we use capital L for inductance. Inductance is unknown. Okay? We have resonance frequency, small letter f, of 200 kilohertz. 200 kilohertz. Okay, recall, kilo is a word problem in mathematics. The word kilo stands for 1,000, 1,000. Therefore, 20 times 1,000 will be giving us 200 times 1,000, forgive me, we'll be having 200,000 hertz. 200,000 hertz in most simplified form. Then let's forge ahead. There is a certain formula for solving resonance frequency. And the formula says this. Resonance frequency has a formula under reactive resonance circuit. We have small letter f is equal to 1 over 2 pi square root of LC. This form for finding a resonance frequency. Any question that demands for resonance frequency, apply this formula. But on this platform, we don't support cramming. All formulas have basis, and I'll show you the roots that led to this formula. Okay, see how we got this formula. Then get the idea, get the logic in resonance circuit. The logic in resonance circuit is this. It's that type of AC circuit. I'm concerned with the series resonance circuit. It's the AC circuit that operates at maximum current and minimum impedance, or minimum resistance, or minimum reactance. A resonance circuit have the minimum or the smallest resistance available and highest current accessible. It operates at maximum current and least impedance, resistance, or reactance. That's what we call resonance circuit. So it permits current flow. Series resonance circuits. Okay, observe. So what do we do now? In order to cancel that resistance that is least, we want to eliminate resistance. Then recall, in resonance circuit, you have three components, circuit components: the resistor, the inductor, and the capacitor. In order to take away the resistance or the reactance that a capacitor and inductor will involve in the circuit, we have to equate the reactances, and they are the same in number, so they can cancel. Okay, so that's the basis of the logic that gave us this formula. In order to get this formula, we'll start this way, that inductive reactance is equal to capacitive reactance. The reactances must be equal so they can do what? Cancel. Inductive reactance equals capacitive reactance. Resonance circuit operates at the minimum impedance, resistance, or reactance, then at maximum current. Then let's forge ahead. So this is starting of this formula. Then inductive reactance is also equated as, recall, inductive reactance is equal to WL. This angular velocity times inductance. Capacitive reactance is equal to 1 over WC. 1 over angular velocity times capacitance. Then let's apply this here with substitutes. Instead of using inductive reactance, I will involve this. WL is equal to, then capacitive reactance, I will involve this. 1 over WC. Then we'll keep pushing ahead. Then also recall, in your simple harmonic motion, recall that W is equal to 2 pi F. Angular velocity is 2 pi frequency. Then we'll substitute again. W becomes 2 pi F L is equal to 1 over 2 pi F C. We'll keep on taking it gradually until we arrive here. We want to prove this formula. We want to prove that formula. It's good you know your formula or the process that led to the formula. We'll continue this over 1. Cross and multiply. Mathematically, 1 times 1 is 1. Then multiply every other thing there. 2 times 2, 4. Okay, we'll push ahead. Pi times pi, pi square. F times F, F square. L times C, LC. Then we'll continue. Recall, we want to prove this formula. We're looking for a resonance frequency. Then I will target making F the subject of the formula. Then I will divide everything with every other parameter staying with F squared. So to divide through, I'll be having F square is equal to, so I'm dividing through with this, that, and that. Just F square. I want to make F square the subject. Recall that it's 1, it becomes 1 over, I'll have every other thing as denominator, 4 pi square LC. Okay. Then to continue from here, okay, to continue from there, F square is equal to 1 over 4 pi square LC. Okay, then recall, I want to prove the form of finding resonant frequency and not square of the frequency. In order to eliminate this square, I will square root both sides. Square root both sides. So I have F square 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 root equal to 1 over 4 pi square LC square roots. Square cancels square roots. I'm now left with F equal to, then rule of third here says, when you have this type of arrangement, it's the same thing as square root of numerator over square root of denominator. 4 pi square LC. This rule of third. Okay? Then we'll continue from here. Therefore, F is equal to square root of 1 is 1. Then rule of third also says, if you have this type of thing, each parameter can pick its own square. This is what I mean. 4 will pick its own square roots. Forgive me. Each parameter picks its own square roots. 4 picking its square root will be square root of 4 times pi square will pick its own square root of pi square times LC will pick theirs. Rule of third. Then we'll continue. F becomes equal to 1 over square root of 4 is 2. Square cancels square roots. R pi. Then there is no way this one retains its square root. We'll be having square root of LC. Then observe, is the same as the formula stated earlier. F is equal to 1 over 2 pi square root of LC. So this is a simple process that led to that formula. So I want to remind you the starting. The starting is just cancel the reactances so that it will go down to minimum impedance and thereby resulting to maximum current. So that's what led to this. Okay, now we can now solve. Then let's now solve the problem. The resonance frequency we know. The resonance frequency is 200 kilohertz. So I'll put it as 200,000 is equal to, kilo stands for 1,000. 1 over, then 2 times pi square root of, recall we're looking for inductance, so it remains there, L times capacitance X, 20 times 10 raised power minus 12. Raised power minus 12. Okay? Then let's forge ahead. So we'll maintain at 200,000 equals to 1 over 2 pi then applying the rule of third. Apply the rule of third here. L will pick its own square root. Square root of L times the capacitance also pick its own square root. Square root of 20 times 10 raised to power minus 12. Then mathematically, recall we're looking for L. This is over 1. Over 1. This cross and multiply. Then place math. Since we're looking for this, notice 200,000 is on the same line with the denominator at the other end. So they can swap. I can swap any of the parameters. Cross and multiply. So L can go up while 200,000 comes down. It's allowed. Mathematically, it's allowed. Okay, this is what I'm saying. So this is what I'm saying. So L goes up. I'm targeting L. So L is equal to 1 and 1. We maintain 1. Then 2 pi. 200,000 comes down times 200,000 times sort of this. We're having 20 times 10 raised to power minus 12. Let me make a better arrangement of this. So I'll be having sort L is equal to 1 over 2 pi times 200,000 times sort 20 times 10 raised to power minus 12. 20 times 10 raised to power minus 12. Okay, observe. When you do this arithmetics, when you solve everything here, you'll be having 0.1779 4 decimal places. 1 over everything here, we'll be having 0.1779. Then recall, I'm looking for capital L and not square root of capital L. What will I do? Square both sides so that the square can cancel square roots. We square both sides. Okay, put square here. Also put square there. So this square cancels the square roots. I'm now left with capital L, which now becomes equal to square of this. I'll be having 0.03165 4 decimal places. Then the unit of inductance is Henry, capital H. Someone's name, capital H. So this becomes our inductance of an inductor. Then going back to our option, you notice that we have fraction. So when you take your fractions there, when you operate on the fraction that will give you the same value as this decimal is option D. Option D, 1 over 32 Henry is the same thing as 0.03165 Henry. 0.03165 Henry. Please stay tuned as we push ahead.